let's finish up what we've got to finish up first, and then I'm going to spend the rest of the time going back through. And if we feel like we need to open up the homework and not close it on Sunday, but open it up until Monday at midnight and spend some time Monday as well, we can do that as also, since this is our first chapter. But I'll definitely spend some time going over homework as well. Okay, I decided I'm going to be a rebel. That grade book was getting on my nerves. Was it getting on y'all's nerves? That you were making like a 5% or something, or a 7%? So I went in and I changed it. So the grade book is now what it should be. So when you go in and look at, if you click on grades at the top, and it'll now be, I think I changed it sometime yesterday. If you click on grades, it'll now be, it won't have zeros for everything else. It'll now be blank, and whatever your grade is what your grade is with your current work. I just couldn't handle it. I know that's what everybody else is doing, but I just couldn't handle it, and I know if it's driving me crazy, it's driving y'all crazy. So your grades, what you see as your average is what your average is right now. Okay, so I did fix that. I did post this, and I want to say I sent it as an email. This is what we talked about, that your homework is due Sunday night, but like I said, if we decide that we need to make it due Monday night, bless you, and we need to talk about stuff in class on Monday, we can change that. The test opens today and will close Wednesday of next week. I did list the testing hours, and we'll talk about that test towards the end of class. You do need to arrive at least 1 hour before they close, because when they close, they're going to close whether you're finished or not. So make sure that you arrive in plenty of time to give yourself, you do have to have your FDTC ID, and they will provide you with the calculator, scratch paper, formula sheet, and I will go ahead and open up 5 and 6 homework so that if you want to start on it, you can. So if we go in here just to kind of show you, and we're going to talk about how to prepare for the test and all that stuff today as well. So if I go in, and we'll show you a couple of things. Okay, so if I go to the homework button, you will now see that there is a due date beside chapters 1, 2, 3, and 4. And it's going to be the 11:59 on Sunday night. So where this did not have a due date, it now has that due date of Sunday at 11:59 for chapters 1 through 4. And if I scroll down, I've already opened up chapters 5 and 6, but those do not have a due date because I won't make that due date until I get close to finishing 5 and 6. We good? Now, another thing that I want you to remember is that we do have a button out there. And I know we talked about a lot on the first day, and I am going to go over stuff today too, but we do have a button. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We do have a button out here that says, I just passed by it. Okay, I just saw it. Where's the information? Homework. It's worked out homework. If you haven't looked at that, this may help you with a few of your, so like, what section were you saying?
I think it was 3-4.
3-4. Okay, so if we go to 3.4, it's not going to have every single one of the problems worked out, but if you go to 3.4, and this won't let me zoom it in here, and it doesn't have the numbers, it will have a similar question, but you can scroll down, and he's got it worked out. The 1 var stats, okay? And we haven't finished 3.4.
Yeah, that's why I was trying just to go by like
what we've done so far. And same thing with 3.2, but we're gonna go over it. We've got to finish 3.4 though. And hopefully that'll answer your questions, but if it doesn't, we'll go back to it.
Okay.
But he's kind of worked out some of the ones that he knows that y'all are going to get stuck on, so hopefully that will help as well. Now, if I come out here, this is what we talked about. Today we are finishing up, really. There we go. Okay, today we're finishing up the notes that we have left. The test opens today until next Wednesday, and right now the homework is due Sunday night, but we can definitely work with that if we need to. And then I have the announcement that I sent you. When we left last time, we had just started talking about 3-4. And 3-4 was about the jumps. How far is a jump? And we said that that jump was the z-score. Data minus mean over standard deviation. And I actually left the problem that we did. This was the problem that we did at the end of class last time. And we talked about biology, bowling, and statistics. This had a mean of 65. This had a mean of 88. This had a mean of 74. And it had a standard deviation of 10, a standard deviation of 6, a standard deviation of 12. And they had different data points. And so what we had to do is we had to find the z-score of each one. And we had to figure out which one was the highest jump above the mean. And that was going to tell us which one was relatively higher compared to the mean. Yay? That's what we did last time. And we're going to do some more of these, so I don't want you to freak out. I just kind of wanted us to get back where we were. Now, this one is going to be very similar. This is still 3.4. It says that babies born after a gestational period of 32 to 35 weeks have a mean weight of 2,600 grams. So in my mind, I'm thinking mean of 2,600 and a standard deviation of 660. If you're born after 40 weeks, which is full term, you have a different mean and a different standard deviation. Suppose a 34-week baby weighs 3,000 grams and a 40-week baby weighs 3,900 grams. What is the z-score for each one? So we want to know what the jumps are. So what I did is they're asking for z-score, so that's data minus mean over standard deviation. So I am going to, and I'm going to draw it down there, but I'm going to do the 32 to 35 week baby. If we do the z-score for the 32 to 35 week baby, let me highlight so that we can look at the 32 to 35 week baby. Nautica. Where do I go to redo my pen? It's off kilter. You want to do it for me? It's like that far below where I need it to be. So I need to know the data, the mean, and the standard deviation of my 32 to 35 week baby. The data, the mean, and the standard deviation of my 32 to 35 week baby. She's going to get my pen back on. You're going to need the IT booze. See, it's kind of heavy on this, isn't it? Oh, gotcha. I was looking on the screen. All right, so I need my data minus my mean over my standard deviation. So if I come back 32 to 35, this is my mean, this is my standard deviation, and so now I need to look for my data. Suppose a 34 week, which falls between 32 and 35, has a weight of 3,000. So there's all the information that I need for 32 to 35. So what am I going to put for my data? What is my data going to be?
It's going to be 3,000.
The 3,000. You have a baby that weighs 3,000. He popped out, weighs 3,000. What is my mean?
2,600.
2,600. What is my standard deviation?
660.
660, okay? So then I go to my calculator and I'm gonna do 3,000 minus 2,600 divided by 660. So this one has a standard deviation of 0.61. So that means that this baby is 0.61 jumps above the average because it's positive. So now we need to do the other baby. Let me move this down just a hair. So now let's do the over 40 baby. So we're going to do data minus mean over standard deviation. So I'm going to do that one in a different color. The over 40 have a mean of 3,500. They have a standard deviation of 470. And if we pop out a 40-week baby, it's 3,900 grams. So I need to fill those in. What is my data?
3,900.
3,900. What is my mean?
35.
3,500. And what is my standard deviation?
470.
470. Very good. So if I go to the calculator on that one, 3,900 minus 3,500 divided by 470. This one has a jump of 0.85 or a z-score of 0.85. So question A says, what is the z-score of a 34-week-old baby? So this is going to be my answer for A. Question B says, what is the z-score for a 40-week-old baby? So this is going to be my answer for B. Question C says, which baby weighs less relative to the gestational period? What would we say for that one? Is less relative to the gestational period. What does less relative mean? We have less relative and more relative.
Would that be the same as like less consistent and more consistent? Okay, so the smaller one, so baby A, because it's 0.61.
Less relative is going to be the lower. More relative is going to be the bigger. So less relative is going to be like the smaller one, the less consistent one. The more relative is going to be the bigger one. So less relative is going to be the smaller one. So it's going to be which baby?
The 34-week.
The 34-week. Very good. Now, I did come down and make it all pretty below, just to show you. Oops. Oh, didn't copy everything I want to copy. Come on. So down here, this just shows you that we wrote out the mean, the median, and the standard deviation, and we did, the data, the mean, the standard, data minus mean divided by standard deviation, data minus mean divided by standard deviation. This was my answer to A, this was my answer to B. Less relative is going to be that lower z-score, which is the 34-week gestational period. Cool? All right. Let you try one. When I make this bigger, it turns kind of, oh, y'all can still see it pretty good. I'll let y'all try this one. This is page 161 in your book. If you have a book, if not, you can look up there. You can grab a book. We're looking at the 100 meter and we're looking at the 200 meter. The 100 meter and the 200 meter. They have different means. They have different standard deviations, so the only way that we can compare them is to look at their z-scores. And I want to know who is better. Is he better in the 100 meter or is he better in the 200 meter? He's going to be my data. He's the one I'm looking at. on your formula sheet, I tell you that the z-score is data minus mean over standard deviation. I give you that information. Where's your computer?
God. this
Oh,
morning.
that sucks. That sucks. So which one would you think is better? Which one? I don't know. I do the easy ones. I give you the hard ones. Think about what he's doing. Look at you. You just heard what I said, didn't you? No. I do the easy ones. I give you the hard ones. Impressive. Got some smart pants in here. You got the answers, you just gotta know what to do. All right, y'all can keep working, I'm just gonna start highlighting. Okay, 100-meter, he did that. The mean of the 100-meter is that, and the standard deviation of the 100-meter is that. Then Ryan did this in the 200-meter. The mean of the 200-meter is that, and the standard deviation of the 200-meter is that. So we have the 200-meter and we have the 100-meter. So I'm going to do the z-score for both. Data minus mean over standard deviation. Data minus mean over standard deviation. So the data is what he actually did. So in the 100-meter, what did he actually run?
45.
Or not run, swim?
45.
45.3. What was the mean of all the swimmers?
48.
48.62, and the standard deviation was 0.98. We good? And then for the other one, Ryan actually did a 99.32, and it was a mean of 106.58 with a standard deviation of 2.38. Now, when you got these answers, the first answer was a negative 3.38, and the second answer was a negative 3.05, and this is where you threw up in your mouth a little bit and said, oh, she hadn't done negatives before. Did I do something wrong? No. What does this mean? This means that Ryan jumped 3 jumps below the average of all the other jumpers. So is that a good thing for Ryan or is that a bad thing for Ryan? What are we doing? We're swimming. So if you're swimming, is it better to swim below the time of everybody else or above the time of everybody else? Below. So if I draw just a regular normal distribution, and if I say this is everybody's average time, I don't know what it is, but if everybody's average time was 30 seconds, he swam somewhere around here. So if everybody's average time was 1.5 minutes, he swam below their time, which means he's swimming pretty daggone fast. Now, I've got to figure out which one is faster. Is this one faster? Or is this one faster? Which one is better? Normally, we say the higher it is, the better it is, because we're talking about grades or we're talking about whatever. But when you're talking about swimming, you want your time to be as low as possible. So for this one, according to the problem, we want the score to be as low as possible. So which one is going to be the best race that he had? The 100 meter. Because it's the lowest score. It's the lowest time. Does that make sense? Now, if this was talking about grades, who had the higher grade, you're going to want this one because the higher grade is the one that's closest to the 0 or the closest to the mean. But if you're talking about a golf score or a time running a race, you're going to want the lowest one. Make sense? All right. Now, here's another one, and we'll just look through this one together. It kind of does the same exact thing. It talks about, I'm not going to make you do 400,000 of these, but it just goes through. We have Ted Williams. This is what Ted Williams hit. His mean and standard deviation are here. Then we have Jose. This is what Jose hit, and this is his mean and standard deviation. So I came down and I listed Ted's data, his mean, his standard deviation. I listed Jose's data, his mean, his standard deviation. Data minus mean over standard deviation. Data minus mean over standard deviation. So this is his z-score. This is his z-score. Are they above or below the mean? They are above. Why are they above?
Because it's positive.
Because it's positive. If the z-scores are negative, we're jumping to the left. If the z-scores are positive, we're jumping to the right. So Ted is 3.8 jumps above. Jose is 2.5 jumps above because they're positive. Now they didn't ask me what are the z-scores, but because the averages are not the same, the only way we can compare them is the z-scores. It says who had the better year? Who was better? Ted. When you're hitting the ball, you want your average of hitting to be higher. So Ted is going to have the better year because he is jumping higher. Versus swimming, you want a lower score. So you've got to kind of think about the sport. So for this one, Ted had the better year because he is higher, because you want those scores to be higher. Does that make sense?
Is it going to be tricky like that on the test?
I don't know. You just need to know all kind. Just know. I'm not going to throw in like a sport that you don't know, like cricket.
Thank you.
All right. Now, this next problem, I'm going to throw in a bunch of vocabulary, but I want to make sure you understand the vocabulary. Your calculator is going to do the majority of it, but I want you to understand what the numbers mean and what the words mean. So I'm going to do one problem with a lot of crap on it. I gave you a bunch of numbers, and I put the numbers in order from least to greatest. Okay? Now, this first number, so they're already in order. I did that for you. The first number is what we call the minimum number. It's the smallest. What do you think we're going to call the last number? Y'all are so smart. Now, if this was a football game, You've got the beginning of the game, which is the minimum. You've got the end of the game, which is the maximum. And you've got the game in the order. And if you come in from either side, what do you call the middle of the game?
Median.
Median. That's like the halftime, right? So if I come in from either side, this is called the median. This is like halftime. It's the middle of the game. We all know that the median is the middle number, right? Now, all the time before halftime, the football game before halftime is right here. If you come in from either side before halftime, what's halfway before halftime?
First quarter. Quadrant one.
Whoop, whoop. We call this quartile 1, or quadrant 1, or Q1. Okay? Then we look at everything that happens after halftime. And we come in from either side. So what do you think that's going to be? The end of the third quarter. So we have, this is the end of the first quarter, and this is technically the end of the second quarter, but we don't say, whoop whoop, end of the second quarter, it's go get beer and go to the bathroom. It's halftime. So median is really quartile 2. We just don't always call it quartile 2 because it's really halftime. Let's go get drinks and food and go to the bathroom. This one is quartile 3. And then again, we don't call this quartile 4, but it's really, the game is over. Let's go home. We don't say it's the end of the fourth quarter. Okay? Now, what I just did is called the 5-number summary. The minimum, Q1, the median, Q3, and the maximum. That is called the 5-number summary. The good news, your calculator is going to do this for you. I just want you to be able to recognize what does it mean when I do a 5-number summary. Okay, that's the 5-number summary. The minimum and the maximum. Quartile 1 is at the end of the first quartile. Quartile 3 is at the end of the third quarter. And then the median is in the middle or the halftime, quarter 2. Okay? Now, another thing that I want you, and we haven't talked much about box and whisker plots, but if you were to draw a box and whisker plot, this is where your minimum goes. This is where your Q1 goes. This is where your Q2 or median goes. This is where your Q3 goes, and this is where your maximum goes. So for this problem, my minimum is going to be 7. This is going to be at 35. This is going to be at 50. This is going to be at 60, and this is going to be at 99. So, let's see if I can get all of that in at once. So when you're drawing your box and whisker, it's like these 5 points are going to be your 5-number summary. Let me highlight so you can see where I put them. I put them here, 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 and here. So your minimum and your maximum are like the whiskers. This is called a box and whisker plot. Here's your box, here's your whiskers. The whiskers kind of go towards your maximum and your minimum. So your maximum and your minimum, and then the box is made up of your Q1, Q2, Q3. And I didn't draw it on a pretty number line, so it would be on a cute little number line. All right, next thing we're going to talk about is what's called the interquartile range. We call it the IRQ. IQR. I think I say IRQ. It's the IQR. IQR. It is Q3 minus Q1. Let me see if I gave it to you on your formula sheet. Y'all, I was